Good morning. This is lesson 8.5, the last lesson in this chapter, talking about the difference between explicit rules, which we've been working with so far, and recursive rules, which is we're going to work with today. So remember, an explicit rule, the term, I can go right to any specific term, and it's defined as a function of its position number. So I have a sub n and some rule or equation that tells me how to calculate that. A recursive rule is different. It specifies the beginning term or terms, could be more than one, of a sequence, and then it has a recursive equation that tells how each term is related to the preceding term. So if I have to find the 25th term, and I'm using it recursively, I have to find 1, 2, 3, 4, 5, all the way to 25, versus explicit, where if I want to find the 25th term, I just use the rule. Look at example 1 in your book. I don't want to spend a whole lot of time with this. They're giving you a beginning term. Notice that the beginning term does not have to start with 1. So here they're starting with a sub 0, and they're telling you that the nth term is the preceding term, a sub n minus 1, plus 4. So when we're using that to write our sequence, we take the first term, well, that was a sub 0, and that's 1. And then this says to find the first term, I take 1 minus 1, so a sub 0. That was 1 plus 4. So I have 1 plus 4 is 5. To find the second one, I'm taking the preceding one, so 5 plus 4 is 9. I'm taking the preceding one to find the third one. So the second one was 9 plus 4 is 13, etc. I think you can see how this works. I didn't do the B one, but look in your book. These are on page 442 in your textbook. So they had the second one. Notice they start with F sub 1, so I can do it as a function, or I can just do it as an a sub 0, a sub 1. Monitoring progress. I think this is so easy, I am not spending a lot of time on it, but if you do them, these are the answers. So for the first one, I should have applied that rule and gotten 3, -4, -11, -18, -25, and then -32. If you want to do these, if you should practice, you can pause the video at this point. I just didn't want to take up the time doing it. I'm trying to keep these short, hopefully painless, or maybe painless. The second one for monitoring progress starts at 162, and then each time you're taking half, so then 81, then 40.5, then 20.25, 10.125, and 5.065. For the third one, I'm applying that rule. I have 1, then 2, then 4, then 7, then 11, and 16. And for the fourth one, you should have ended up with 4, then 7, then 13, then 25, then 49, and 97. So if we're looking at recursive rules, the first thing we find is the first term, and then we have to find the pattern. So if I'm looking at an arithmetic sequence, we know that it's going to look like the first term. I'm going to add whatever that next, or I'm going to add the first term plus a common difference. And so it's going to look like whatever that term was, plus the common difference, and I'm going to do it however many times I have to do in order to get to the one I'm looking for. And for a geometric sequence, that's going to look like a common ratio times that preceding term. So look at example 2 in your book. The deal when you're looking at these is to find the pattern and recognize the first term. Well, first term's easy. Finding the pattern is sometimes what gives us trouble. Always start with arithmetic and geometric. So I'm looking for a common difference. And the first thing I see is they're 10 apart. So I know this is an arithmetic sequence. That makes this really easy. My first term is 3, and each succeeding term is going to be whatever the term was that came before it, plus 10. So my sequence is going to look like the first term, and my rule is a sub n equals the preceding term, so a sub n minus 1 is how we write that, plus 10. And in this example, that was that. For the second, the B part in that example, so I'm starting with 16, 40, 100, 250. Well, I can tell there's not a common difference. But if we divide 14 divided by 16, 40 divided by 16, 100 divided by 40, 250 divided by 100, I'm getting 5 halves. so they are related with a common ratio. And to write the recursive rule, the first term, a sub 1 is 16, and a sub n is 5 halves times whatever that preceding term was. So 5 halves times a to the n minus 1. If I'm looking at example 3, these are not geometric and they're not arithmetic. So the deal is you've got to find the pattern. So I'm looking at this one. The first term is 1, and it's 1 again, and then 2. But then look what happens. 1 and 1 is 2. 1 and 2 is 3. 2 and 3 is 5. So I can see what the pattern is. And so this time I need 2 terms, because what I'm doing once I get past that second term, third term, is I'm adding the 2 previous ones together. So for this rule, I need to specify the first 2 terms. So a sub 1 is 1, and a sub 2 is 1. And then the rule is a sub n is the sum of the 2 preceding terms. So a sub 4 is the sum of 1 and 2, which was the second and the third terms. Look at the B example. It's 1, 1, 2, 6, 24. So what's going on with that? Well, sometimes it's really handy to start with a sub 0 instead of starting with a sub 1. So if I let this be my first term be 0, then I notice that my first term is 1 times, or my second term is 1 times a sub 0. The second one is 2 times a sub 1. The third one is 3 times this one. So I've got 0, 1, 2, 3. 1 times 1, 2 times 1, 3 times 2, 4 times 6, so that you can see how it's working. When we write our rule, I have to specify the first 2 terms, and I'm also telling my reader that I started with 0. So a sub 0 was 1. A sub n then is n times a to the n minus 1. So if I'm looking for this term, it was 1 times the preceding term, which was 1. If I'm looking for, and I have to iterate because that's what makes it recursive. At this point, I'm going to try to pause this, if I can do this, so that I can erase. I'm trying to speed us up so I don't have to have you sit there while I do it and see if this works. Okay, so if you've looked at monitoring progress and tried to do that, these are the ones that are at the bottom of page 443. Your job is to write the pattern. And so the first job is to find the pattern. So when you're looking, this is geometric, so it's pretty easy to see. You're just multiplying each term by 7. And so when you wrote the rule, specify the first term. So a sub 1 was 2. And the rule for finding the next term was 7 times each preceding term. When you're looking at 6, for monitoring progress number 6, looking for that pattern, notice that each one was 6 less than the one before, so your pattern was you were subtracting by 6, or the arithmetic sequence, and the common difference was -6. When we wrote that as a rule then, specify the first term, so a sub 1 was 19, and the rule was whatever that preceding term was, subtract 6. For number 7, looking at that one, it's 11, and then 22, and 33, and 44, and 55. So you were adding 11 each time, so it was, again, an arithmetic sequence. Specify the first term, which was a sub 1 was 11, and the rule was take that preceding term and add 11 to it. So a sub n equals a to the n minus 1 plus 11. And for the last one, it was 1, 2, then 4, then 8, and 32. So not arithmetic, not geometric. So to find that pattern, look what happened after the third term. You're just multiplying the preceding 2. So 1 times 2 was 2, 2 times 2 was 4, 2 times 4 was 8, 4 times 8 was 32. So to write that as a pattern, we had to specify the first 2 terms, because remember you were multiplying 2 together. So a sub 1 was 1, a sub 2 was 2. And then after that, the recursive rule, the formula, is a sub n equals a sub n minus 2 times a sub n minus 1. So if I'm reading that, that just tells me to find this third term. I'm multiplying the two preceding ones together. Then look in your book. This is example 4. Anytime you have two ways to do it, then you have to translate between one and the other. So for example 4, given an explicit formula, they wanted you to write the recursive. So when we did that, look at what they gave you. Given a sub n was -6 plus 8n. What does that look like? Arithmetic sequence. So find the first term. So I'm going to use, remember for a recursive rule, I have to find the first term, I have to specify the first term or terms, and then tell how they're related. So given that we recognize this as an arithmetic sequence, easy to see that that common difference is -6. So all I really need to do now is find that first term. So I plug in, let n be 1 unless I'm told otherwise. So -6 plus 8 was -2. And that means my recursive rule is going to be specify the first term, a sub 1 is -2. And then specify the rule, a sub n is a sub n minus 1. So that preceding term plus that common difference of 8. When I'm looking at B in that example, we were given a sub n is -3 times 1/2 to the n minus 1. Again, we love it because it's geometric. That means it's easy to work with. Find the first term, so I'm letting n be 1. So -3 times 1/2 to the 0 is just -3 times 1, which is just -3. So my first term, a sub 1 is -3. And my recursive rule then is specify the first term, and the way that they're related is 1/2 times whatever that preceding term was. So 1/2 times a to be sub n minus 1. Example 5 was going the other direction. Given a recursive rule, write the explicit rule for that. So given that their first term was -5, and they were related by multiplying each or subtracting 2 from the preceding term, goodness, I can write my general rule. Remember, for an arithmetic sequence, easy to see that this was an arithmetic sequence. And so I know my general form is going to be a sub n as the first term plus n minus 1 times that common difference. So my first term was -5, n minus 1, I don't know, but I do know that that common difference was -2. And so I'm just distributing and simplifying to find that the explicit rule is a sub n equals -3 minus 2n. The second one in that was a geometric sequence. And so they specified the first term, a sub 1 is 10, and a sub n was 2 times whatever that preceding term was. So for the explicit rule, a sub n, the general form is a sub n equals a sub 1. So I need to find that first term, r to the n minus 1. So if I plug in and I let n be 1, I have 10 is my first term, and 2 to the n minus 1 would be my common ratio. Again, let me pause this and let's go look at monitoring progress. And all we have left to do is that one word problem. So hopefully this will end up being a short video. You never know, but